All right, I am recording. Good morning. Welcome to day 53 of the Rankin Technical College online AWD1000 Web Development Technologies class for fall 2023. Now, I'm going to change this around a little bit. I'm not going to get into why, but I am going to go over this, but I'm going to wait until Monday. All right. And like I said, I don't want to discuss the reasons why, but you can. So if you have not done JS hot number 2, all right, I will do that first thing Monday morning. If you have got it turned in by then, you can still get partial credit. If it's not turned in by then, you will get you'll get a 0. All right. What we are going to cover today, just starting in a couple minutes, are chapters 16 and 17. Now, these are really complex topics. Chapter 16 is how to work with objects. Let me just tell you really quickly that next semester, those of you who will take the AWD1000 C# programming class, we've got a book that's got about, I don't know, 20 chapters in it, something like that. It's another Muroc text, just one book, but the first 11 chapters do not talk about objects, but starting with chapter 12, they do in a lot of depth and breadth of coverage. So this isn't something that's going to go away. All right. In chapter 17, they talk about, as it says there, functions, closures, and modules. And I gave you a list of 9 URLs with the email this morning, and I'm going to go over most of those, but again, not in a lot of depth or breadth of coverage. All right, we may be done by 10 o'clock today. It may even be earlier. I don't know. All right, then on Monday, we're going to finish up the text. I'm going to go over JS hot number 2, and I will hand out your final. All right, so we'll do all that stuff on Monday. Now, I mentioned this the other day. I want to say it again. I want to show you this again. All right. What I am asking you to do, not for this Sunday, but for a week from this Sunday, is in the free code camp thing. Now, most of you, not all of you, but most of you have now finished the basic JavaScript that had 113 lessons in it. I realize not all of you have for whatever reason, but most of you have. After that, then, what I want you to do by not this Sunday, but next Sunday, which is the 19th, I want you to go over the 29 lessons that are in this ES6 thing. All right. Some of it will be duplicative of what we've already gone over in chapters 12 through 15 so far. And we'll go through in 16, 17 today and 18, 19 on Monday. But again, that's all we can do is try to prepare you for stuff that you're going to need to be using, etc. Things like arrow functions, destructuring, classes, promises, modules. So you'll notice, again, today we're going to talk about classes, and there's going to be a whole thing in here that's going to be on classes. And it's not even so much that you're going to look at all this and say, hey, you know what? I totally 100% understand this. All right. But the idea is you are at least getting an initial exposure to it. So the homework, I called it homework 8, 9, and 10, which again will be due by midnight, Sunday the 19th. You were supposed to have done the first 6 of these already. That's 20%. All right. Then you go up to 40% for chapter 8, up to 60% for chapter 9, and then finish it for chapter 10. I'm looking at it, hopefully that you look at it, that if you get this done, basically it's worth the equivalent of a test because there's 4 25-point assignments in there. So again, it is the equivalent of a 25 times 4 of a 100-point test. All right. Okay. So with that said, let's just talk about what we're going to talk about today. All right. So the first thing in here talks about objects. And basically, you can look at anything in life as being an object. Sometimes what some books will do is they'll define an object as a noun, a person, place, or thing. But it can also, technically, an object can also be a concept. All right. Most of the time when you talk about an object, it is a person or a place or a thing. Now, if we look at the examples that they have, or the one here, all right, objects are made up of properties and methods. Notice what the properties are. All right. They're things that kind of determine or distinguish one thing from another thing. What do I mean? Well, notice that this car is a Fiat 500. You can see what it weighs and what its color is. Now, another property in here that would be different for each car object would be a VIN, or a vehicle identification number, because at least supposedly every car that's out there has a different VIN number. All right. Now, the methods are the behaviors. So cars can start, cars can stop, cars can drive, cars can brake. There's other things we could add in here: accelerate, cars can turn, etc. But the thing is, when you create an object, the object only has the properties that you give it. The properties only have, or I'm sorry, the object only has the properties you give it and the methods you give it. That's it. It doesn't have anything else. It doesn't know about anything else. So if we did a name, but we didn't do a model here, this object, car object, wouldn't have a model. All right. When you create these, and this is going to even make it sound a little bit more confusing, and I don't mean to. This is an object. And what an object is it's an instance of what's known as a class. And a class is a template. So in other words, if we said that every single time you create a car, regardless of the type it is, etc., but every car would have a name, a model, a weight, and a color. Every model would have a start, a drive, a brake, and a stop. All right. Now, they're going to be different. For instance, if you've ever driven a car with a stick shift, you drive that kind of car differently than you drive a car that doesn't have a stick shift. And if I was going to go in and create a Mercedes that was, I don't even know what their numbers are, like an SL 500 or something like that, it would have a different name than what's shown here, a different model number, probably a different weight, and conceivably a different color. So what happens when you start to do this stuff is you first create a class. I want to give you one more example because, again, sometimes people get confused. Now, I am sitting right now in a conference room at Rankin, all right, at the Rankin-Wentzville campus. I can look outside a little bit, but if I went outside and looked to my left, across the street, there is a huge lot that's out there. It looks like a farmer's field, all right? But imagine that a developer came in and bought that. I have no idea how many acres it is. Let's pretend it's a couple hundred acres, all right? And some developer comes in and buys it, starts to put in streets and lights, etc. But then comes to the idea that they can put up 100 houses on this 200-acre lot. They're going to put up 100 houses, all right? And they bring in some kind of an architectural firm, and they decide that they're going to come up with 5 house plans, and they're just going to stack them. So 1, 2, 3, 4, 5, then another row of 1, 2, 3, 4, 5, and they're just going to set it up like that. Each of these house plans would be what's called a class. All right. And each one of them would have things like, how many windows does it have? How many doors does it have? Is it a 2-car garage or a 3-car garage? Does it have 4 bedrooms, 3 bedrooms, 5 bedrooms? How many bathrooms, etc.? So each one of those architectural plans would become a different house class. Each one of the houses that are created from those plans would be a house object. In the same way that what we see right here, somebody would come in and create a car class. And then what you have right here showing on the screen is a car object. So an object is known as being an instance of a class. In fact, the idea behind creating an object from a class is it's called instantiating because you're creating an instance. All cars would be expected to have properties, these properties, and methods, these methods. That doesn't mean that these properties are all going to be the same. They're not, because no two cars are the same. All right. And again, you know, the way that things work today, with some cars, you still have, with some cars, you have a keyless start. With some cars, you need to put the key in. So the way you start it is going to be different. Again, I mentioned this before. The way you brake is different. For example, if you're driving a car with a stick shift and one without, that kind of thing. So as it says, all cars will have the same properties. All right. But the property values will be different from car to car. All cars will have the same methods, but the way they're actually implemented could be different. All right. So, I mean, they give some examples in here. I don't want to get too far into it because I don't want to confuse anyone any more than I already have. All right. Now, notice what it says here. Objects are variables. We learned about a special kind of variable that we talked about in more depth and breadth of coverage yesterday, and that was an array. Like an array, as it says there, objects can contain many values. So when you create a new car, this is one way that it can be done. And one of the things we talked about yesterday was key value pairs. Type is the key, fiat is the value. Model is the key, 500 is the value. All right, that kind of a thing with key value pairs. So key would be color, value would be white, etc. As it says, they're typically written as name value pairs. And as I mentioned, when you do this, you are responsible for setting this stuff up. So an object is only really a class when you create it. It only has the abilities that the person designing it gives it. Now, they showed one way to create them here, and there's another way in here. There's different ways that you can do this. Here's yet another way, breaking it up over multiple lines. This is a good example here because it's a person. This is something we can all identify with. We all have a first name. We all have a last name. We all have an age. We all have an eye color. We could add more things onto this if we wanted to. All right. Again, those are properties. That's the property name. That's the property value or key value pairs, however you want to mention them. The way you access this stuff, there's two ways. And they show them both here, and they're going to give an example of each. I will tell you, probably 99% of programmers use this way. And probably 1% of programmers do it this way. They both do exactly the same thing. So why do more people do it like this? Because it seems to be more intuitive to do it like person dot last name, as opposed to person bracket, and then last name like that. So when you do this, it's the name of the object, period, then the name of the property. So if I wanted to set my last name, I'd say person dot last name equal double quote Scott double quote semicolon. Or I could do it like this, where again, I would just say equal double quote Scott double quote. All right. And again, methods they call them actions, totally fine. They're basically behaviors. They're what you want to allow the object to be able to do. So if you look at the example here, an object has 1, 2, 3, 4 different properties. Then we gave it a method that goes in and combines the first name with a space with the last name. All right. So as it says, a method, basically, it's a function of an object. All right. There's nothing wrong with their verbiage. I just use my own. So here's an example of how you could do that. Now, what tends to confuse people, we got a new word in here. You may or may not have noticed, and that word is this. All right. This that you see right there refers to whatever it is you're talking about. All right. In the current case, this means the current person object. All right. And you might think, well, that's kind of weird. And it is. All right. And we do similar things in C#. And actually, this is JavaScript that you see right here. But if we were using the Java programming language, it would look remarkably like what you see right here. All right. So they talk about this. Again, I don't want to confuse you. All right. But typically, as it says, it refers to different things depending on how you're using it. And they give you a whole liturgy here of things it could mean. All right. You can take a look at that. I'll let you look at that on your own. And then this is how you'd invoke it. This looks almost just like what we just looked at for a property, except there must be parens in it. If you leave the parens out, the system thinks that it's a property and not a method. Sometimes there'll be something in those parentheses. I mentioned this before. We could set up a method for a person that was called sleep, where we'd have to provide in there how many hours it is they were going to sleep. Or maybe another method called eat, and we'd have to provide something in there as far as what it is they're going to eat. So there's different types of methods that you can create. All right. It says do not declare strings, numbers, and booleans as objects, even though you can, but you shouldn't. That's what they're saying here. And again, they've got some exercises here. I'm not going to run through any of those. All right, this was just designed to give you a quick little introduction into this before we go into it in the chapter. All right, now the other thing I gave you for this is the object definition that's in developer.mozilla.org. This is much more extensive and expansive than what I just went over with you. But if you want a little bit more and you want to take a look, as you can see, it's going to be pretty long. All right. And there's stuff I did not talk about because, again, it's so easy to get over people's heads in this stuff. And the idea of teaching you about objects in one class period, really in one part of a class period, in many ways, it's like all you can be is introduced to them. All right. So let's go into, let's go into the actual chapter then. So we are in chapter 16 right now, how to work with objects, okay? And they mentioned, so far in this book, we've worked with numbers, strings, dates, and arrays. This chapter, more than anything else, is on how to create your own data types, your own object types in this way. So as you can see, some of the stuff that's in here won't be new. In other words, miles per gallon. We've already looked at miles per gallon, but they're going to redo the miles per gallon app using objects, just so again, you will see what those are like. All right. So we get some basic skills and the miles per gallon app, then a little bit more generic stuff on classes, then a trips app. All right. Then we work with prototypes. Now, there's a part of me that wishes they didn't even put that part in this particular book. JavaScript is very unique in the way that you work with objects. And in fact, the whole field of working with objects and classes is typically referred to as OOP or OOP for object-oriented programming. Now you can Google object-oriented programming and you can find out all the things that basically any language has in it, etc. And that's totally fine. The reason I'm bringing that up is recently, like within the last 10 to 15 years, you can write object-oriented programs in JavaScript in a way that's pretty similar to the way you do it in other languages. But before that, you worked with something called prototypes, which are fairly unique to JavaScript. All right. Most people who have been programming for years and years and years in JavaScript may still use prototypes. Anybody who's started programming recently probably has a minimal use of prototypes at best and may not use them at all. We'll go over them, but it's just a couple pages in here. And then as it says, there's some more skills. And finally, they go on to that task list that we looked at yesterday, which is kind of a to-do list. But again, they're going to go back and they're going to rewrite that using objects. So let's get going. All right. Again, I don't want to read to you. And one of the reasons that I showed you the example that I did was so that we won't have to spend a lot of time going over stuff. Now, if you remember yesterday we did this. I did something like this. So we could come in here and say, as an example, all right, let me make this a little bigger. We could come in here and say something like, let students equal, and that created a brand new array that was called students. All right, I'm not going to talk about arrays today, but what I want to mention to you is if I did this, all right, that's not an array of students. That's creating a student object. So for instance, I could do this and come in here and do stuff like this. All right, I could come in here and say, as an example, first name, Jeff, last name, Scott, and I can keep going. I could put in a height and a weight and anything I wanted to put in, all right, would be totally fine because that's up to my discretion to put that in, to put in what I want to put in here. Now, these are properties, all right, but I can also come in. If you look in here, this example they show right here with his get total, that's a method, all right? So properties, again, are kind of pieces of data, and methods are routines that typically manipulate that data. All right, in a nutshell, that's what we're talking about. So this is going to create a blank object called invoice, and here we're initializing it. We're saying that each invoice, all right, has got a tax rate that looks like 8.75%. And when we want to use this object, we have to pass in a subtotal to it. All right. And then we figure out the sales tax by taking that subtotal, multiplying it by 8.75%, and then we return the subtotal plus the sales tax, or in other words, the final total. All right. So when you want to refer to something that's inside of an object, you use the dot. And as I mentioned before, all right, the dot followed by something that doesn't have parens after it. This right here is a property. This, since it does have parens after it, is a method. Actually, this is a method call. So if we say 100, it's going to be 100 plus 100 times 8.75, which would be $8.75. So it would return 100 plus 8.75. All right. Now, you can even get more confusing. You can have an object within an object, which gets to be pretty ugly, but you can do it. All right. What I want you to take away from this is classes are used to create objects. So classes are templates that we use to create objects. Objects have properties and objects have methods. Properties are pieces of data associated with an object. Methods are functions or routines that you can use to manipulate an object and typically to manipulate that object data. All right. That's more than anything else. That's what I wanted you to get out of this section that's in here. because there's a lot of stuff that's in here. Some of it may make sense. Some of it may make little to absolutely no sense to you. All right. And that's okay. Now, they even show you in here because as time goes on, typically with most programming languages, all right, not all, but most programming languages, features are added, features are dropped from a language, features are modified in a language. So if you look in here, you'll notice in the examples, they show you traditional syntax, and then they show you concise syntax. Now, in this case, it's not buying you much. Basically, we're getting rid of the colon and we're getting rid of the word function, but it's a little easier to work with than the other one is. Both of them still work. Both of them are still out there. Both of them are still being used. Typically, what happens with something like this is there'll be a recommendation made that you use the newer syntax whenever possible. All right. In fact, sometimes, and you've heard this term with HTML, sometimes what happens is certain things in a language become deprecated. All right. And somebody asked me once, give me a good definition of deprecated. All right. And I said, guess what? We're all deprecated. We're all going to leave this earth at some time or another, but most of us at least don't know when that'll be. In much the same way, when you're talking about things in a programming language or HTML or any kind of language that have been deprecated, then what they're saying is there's somebody has come up with what's considered to be a better way of doing it than that way, and that's what you should do for new development. But there's a ton of old development out there that still does it the old way. So we're not getting rid of it. We're just recommending that when you do new things, do it the new way. All right. Here's another example. Okay. Two different ways that you can initialize something. And again, I don't want to get into it in too much depth, but you'll notice in here, these two look the same. But what they're saying is, if you've got something called name and it's going to be a person's name, if you've got year and maybe that's a birth year. So if you've got the same name, year, why repeat it? All right. As it says, this removes the repetitive syntax and it makes them more concise. And typically it makes it easier for people to understand. Right. It's called the shorthand syntax. All right. Extending or modifying an object. What you can do with an object is you can add things to it. So in other words, if I made a person object and I gave them all those things I talked about before, a first name, a last name, a height, a weight, etc., and I gave them just two properties. Let's just say I gave them a property to sleep and a property to eat. And somebody came across and said, you should also give them a property to drink. Well, you can go back and you can add that later. All right. It's not going to hurt anything to do that, in other words. All right. You can remove things from properties. All right. Now, you may find this confusing, but it says two constants that refer to the same object. All right. And if we look at the example right there, we've got const today equal new date. So today it's now a date object that has today's day, month, or month, day, and year, and the current time. All right. But if you copy it, which is what you think would be happening right here, when you say const now equal today, it's not a true copy. What it copies is this has got literally an address in memory somewhere associated with it when you put in this first line. When you do this, basically it now holds in here that address. These two things are now aliases, whatever you want to call them, with one another. So if you change one using today, it changes it also using now, and vice versa. All right. So again, the key takeaway here is, as they say, once you create an object, you can add new properties and methods to it. Now, you might think, well, can I do that with like built-in JavaScript objects? The answer is yes, you can. You could even take things that someone else has created or that the language has itself, and you can add to them. Typically, when you do that, you use prototypes, which we'll talk about in just a few minutes. All right. Now, we've talked a little bit in the past about getters and setters. We have talked about this in terms of programming languages and the like. All right. Now, getters are known as accessors. All right. Tell you a very quick story that none of you probably care about, so I'll make it short and sweet. I have 3 daughters. All 3 of my daughters are adopted. My first daughter, we saw her the day after she was born. And when we came in there to the hospital, they had baby Scott on there. All right. And the nurse came and said, what's her name going to be? And my wife said, it's going to be Taylor. Well, that was setting her first name right there. All right. Really, that was the only time it was set other than to put it on the birth certificate. All right. But for the birth certificate, they needed to know her first name, her middle name, and her last name. That was a get. So if you ask somebody something, it's a get. If you tell somebody something, it's a set. So a get is basically read only, whereas a set is basically write only. So in most programming languages, they allow you to use getters and setters. They're used a lot in C#. You'll see that next semester. They're used a lot in the Java programming language as well. All right. And they talk about it a little bit more here. I don't want to sit and just read to you. All right. Typically, getters are called accessors, and typically setters are called mutators. But sometimes people call both of them accessors. The only thing, about most things in IT is people can't agree on much of anything. All right. So how to create and use JavaScript libraries. All right. Well, first of all, let's talk about why you would want a library. If you've got code that you are constantly using in different routines, for example, maybe you write some kind of a special sorting routine. We looked at sorting a little bit yesterday, but you write some of your own kind of little sorting routine, and you want to be able to use it all over the place. You can take that code, put it into its own file, put that file into a library, bring the library into any program that needs it. So as it says, for as far as the benefits here go, they let you group similar functionality in a single file. They make the code easier to understand, maintain, and reuse, and they encourage the separation of concerns. All right. But when you think about it, even more than that, okay, you can write yourself library routines, test the heck out of them, and then use them in other programs with a pretty good knowledge that they should work because they've already been tested. All right. So what they're doing is they're putting this in here that you see right there. They're putting it into a file called lib_mpg. Then in the script tags, they're bringing that file in along with a main file. And you'll notice that main file can use the MPG that was defined in here. All right. It's a way of basically sharing. And library is a good name because when you think about it, that's kind of what happens in a library. All right. So as they mentioned here, a JavaScript library is an external file that can hold virtually anything you want to put into it. All right. They can be simple. They can be very complex. And guess what? You've already worked with a JavaScript library. jQuery is an example of a JavaScript library. All right. As they say there, the library is normal JavaScript. You can include the libraries in your application by using the script tags. All right. and then start using them immediately. So the next thing that's done in here then, again, is this MPG program, miles per gallon, okay? And it's been redone, or, this looks the same as what we've been doing for much of the semester while we've been in JavaScript. The HTML hasn't really changed, other than we're now adding, you'll notice we're adding jQuery, we're adding a library file, and we're adding our own mpg.js. All right. There is absolutely nothing wrong with the example that they put in here. The only thing I would tell you is, to a lot of people, when you look at this, you're like, okay, I get this. I get, what it is, but it doesn't seem like it's buying me a whole heck of a lot. All right. Now you've got to realize in here that with the examples that they're giving, they are simplistic examples. I mean, there's not much code. This is the whole file, and there's only about 10 or 15 lines of code in it. All right. But in a big application, you could conceivably be working with different kinds of objects that you defined, and you could have literally scores of library files that you were including in your JavaScript program. All right. And what makes that advantageous is, if you're working on something that is unbelievably complex, you could have groups of people working on different objects, and then you bring them together. Another group might bring all that together and then test the stuff. So by putting it into separate libraries, you can do testing of your own code before you bring it together and test all of it. So we've got MPG object in here. You'll notice that it has two properties, a miles property and a gallons property. Then it has an is valid method. All right. And with that is valid method, if it fails validation, meaning that if either field is non-numeric, or if either field had a negative number inputted, you can see in both cases they return false. Otherwise, they return true. And the only way that you're going to call the calculate method that you see right there is if they actually return true. All right. And that's what they show you in the file right here. And you'll notice when you look at it, again, in the HTML that we just looked at a second ago, this is where you bring in that library file and your own file. All right. And of course, jQuery as well. But when we come into here, now we're working with an MPG object, and that object was defined in here. That's why we can say the name of the object, MPG dot, the name of the property. Remember, there's only two properties an MPG object has, miles and gallons, because that's what we gave it. And there's only there are two methods for an MPG object, is valid and calculate. And notice we're not going to call calculate unless this is valid returns true. And if it does not return true, we're going to show a message that says both entries must be numeric and greater than 0. All right. And then this is just our clear button right here. All right. I can't think of any other way to explain it than the way that I am explaining it. And I'm not saying my explanations are stellar. I'm just saying I'm trying to put it in what I consider to be the easiest way for you to hopefully at least understand. All right. Now let's look quickly at this, how to work with classes. It says if you've worked with other programming languages, and probably most of you have not, it says you're probably familiar with classes. So at this time next year, you will understand C# classes, next semester, I should say. You will understand C# classes as well. Notice what they say, very similar to what I said before. You can think of a class as a template that defines properties and methods of an object. Not an object, but it's a template from which you make objects. And as it says, languages that use classes to define and create objects are called class-based languages. I've never heard them called classical. All right. Now it says, in contrast, JavaScript really behind the scenes does things a little bit differently. And what you'll see in just a few minutes is there's yet another way that you can do this that we haven't even talked about yet. All right. It says there that JavaScript uses prototypes to create objects. That's the older way of doing it. And as they mentioned, modern JavaScript provides a syntax that's similar to class-based languages. That's what we've been looking at thus far. And as they mentioned, it's considered a best practice to use the newer syntax for development. That said, there are still millions, if not more, lines of code out there that use the old type of way. And they use that because, at least at the time, that's all that was available. All right. So they give you a few things in here. And if you look, notice here, we're setting up a class. It's not the object like we saw before. It's a class. What is this saying? All right. Well, the name of the class is invoice. This is one of those times when you create something in JavaScript, it should start with a capital letter. All right. When you create your variables, when you use let and you've got a variable name, it should always be lowercase. Now, we haven't even talked about this yet, but when you create a new object based off of a class, the first thing that happens, like in this line that you see right here, const invoice equal new invoice. When that line hits, it comes up to here and it looks for a special method that's called a constructor. The constructor is designed, it's a method that's designed to run, all right, once an object has been created. So what is this doing? Basically, it's declaring two different variables, subtotal and tax state, and it's setting them both to null. And hopefully you remember from other classes, null basically means unknown. In addition, this class, other than a constructor, it also has another method in it called getTotal. So that's the template from which you create objects. So then down below, we create an object. Const invoice equal new invoice. That means invoice right here, instantiate or create a new invoice object. So again, it comes up to class invoice. Then after you do that, we do want to set the subtotal and we do want to set the tax state ourselves. Now, what they're showing right here is they're creating the object and they're immediately setting the subtotal and the tax rate. It doesn't necessarily have to work like that. There could be more code that you're not seeing in between these two lines. Or you could ask the user, what was the subtotal? Then ask the user, what is the tax rate? All right, so there's a bunch of different ways that this could be done. All right, notice if you try running this line right here and you don't put in the word new, you'll get an error or an exception. All right. Now here they're coming in, and this is where I said it gets to be a little bit confusing. You already saw this. This is exactly what we looked at, except now we are saying that we're passing something in. Here, we passed nothing in. That's why it was null. Here, we're saying, no, we're going to pass stuff in. So when you call this and you create a class object, you must pass it in two numbers, one representing a subtotal, one representing a tax rate. That's all fine and dandy. All right. But when you do this, what they're saying here is there's two ways you can write this. Pass in nothing or pass in something. So you've really got two different constructors for the same class. All right. And believe it or not, there actually is a name for that. When you've got two routines that have the same name, but what's in the parentheses are different. So here we've got two values in the parentheses. Here we've got nothing in the parentheses. All right. Those are called overloaded. All right. So we've overloaded right there the constructor. There's two of them, meaning that you can call the constructor and pass it in nothing, or you can call the constructor and pass it in two different things. All right. All right. And if you don't like it, it's not trying to be funny here, but it gets nothing but more complicated after this. Okay. You can have inheritance with these things. Now, inheritance in many ways, not every way, but in many ways, works like genetic inheritance. What does that mean? Well, I had two people I used to work with, and I'm not going to say their names or anything else. It was in Wisconsin, it was in Illinois. You wouldn't probably know them anyway, but they ended up going out together and they ended up getting married. They were both terrific people. I played basketball with one of them and I worked in the same group with another one, with the other person. They both had big noses. All right. I'm not saying that to be critical, but they both had big noses. All right. They had a baby, and the baby was born with pretty much a big nose for a baby. That's genetic inheritance. All right. Now, that baby, what can it do as it grows up? Well, it can live with a big nose. All right. It can go and have a nose job. And really, there's not much more that it can do than that. It's not like they can take that nose off and put on one they wanted. But that's kind of what you can do with programmatic inheritance. If you don't like the way something was inherited, you can change it. All right. So when you look in here, we've got this person class. All right. And that says any person has a first name, a last name, and you can combine them together for their full name. Then you'll notice we've got another class. So there was a person class. Now there's an employee class. And that word extends means that an employee is a type of person. An employee is a person. All right. So, I'm not going to draw it for you, but if you could imagine that you were drawing kind of like an organization chart for a company, and you'd have somebody on top, and then you'd have somebody underneath them that would report to them. All right. In the same way you can draw inheritance diagrams. But again, when you are using inheritance, you are using or creating what are called an is-a or an is-and relationship. In other words, an employee is a person. All right. If you're still confused, imagine we were talking. Let's say that I created something up here that we're not even going to show, but I called bank account. And all bank accounts have what? Well, they've got a name of somebody who has the account. They've got an account number. They've got an account balance, etc. So I could create a class called bank account. Then I could create a couple of other ones. One that was maybe called checking account and one that was called savings account. And both of them would extend bank account. That's the way a lot of software is written, is you come up with relationships like this. All right. And depending on the language you're using, not all languages support object-oriented programming. Not all languages support inheritance. Most newer languages do. All right. And again, they use the extends or something similar to this. So as it says, inheritance lets you create a new class based on an existing class. By default, the new class inherits everything from the parent. Not only that, this is an example of, when you think of genetic inheritance, like the example I gave you before, that baby probably got something from the mother and the father. But JavaScript, like C#, only allows single parent inheritance. You can't inherit from two different parents, as an example, only from one. All right. The parent class is known as a parent class. It goes by a lot of different names, a super class, etc. The child class is called the child class. It's called the subclass, etc. They go by a lot of different names. All right. So they give an example in here of using inheritance. Again, it's a very simplistic example. It doesn't look like it, but it is in that there's not much code here. All right. And there's something in here again, probably not going to make much sense, that says super. All right. And super says, call the constructor, not my constructor, my parent's constructor. All right. And again, I struggled even whether to give this lecture today just because I thought it's going to be so darn confusing, but at least you've heard the terminology. So you'll notice in here when to use inheritance, the first thing it says, what I mentioned, when there is a or an is an type of relationship more than anything else. That's when you create inheritance. So for example, if I created a class that was called mammal, okay? And underneath mammal, let's say that I started creating classes underneath that. So I create a class under mammal that's called dog. And underneath that, I could create a bunch of other classes, maybe Saint Bernard, Chihuahua, Beagle, etc. So now what I'm doing is I'm creating an even bigger class hierarchy that has even more levels to it. And that kind of stuff, again, is done a lot. All right, that was inheritance. Then there's composition. So let's say that I create a class that's called clock. And I say, well, what can you do with a clock? Well, first of all, what properties does it have? Hours, minutes, and seconds, not much more than that. But what can I do with a clock? I can set the time, I can get the time, etc. All right, so I create a clock class. Now somebody comes along and says, okay, well, in this program that I'm doing, I need to work with an alarm clock. Why would I want to go and recreate a new class called alarm clock when I've got a clock class? So when you take a simple object and put it inside of a more complex object, that's what's known as composition, because the object is at least partially composed of another object. All right, I'm just going to leave it at that because, like I said, okay, that's a has-a relationship, and I don't want to confuse you any more than I probably already have. All right. The other thing about this that they mentioned is encapsulation. And if you remember, we talked about this either the other day or earlier this week. We talked about implementation versus interface. And the interface is what you can see, and the implementation is how it works under the hood. It's interesting because this morning when I went in, I go into one building at Rankin, and then at 7:30, when people start coming in, I go into the building I'm in right now. Well, in this building that I was in, I was talking to a student. He's an IT student. He's working on a networking degree right now. And he was telling me how years ago he took a class, all right, and that class, he said it was on the C# programming language. I said, did you learn a lot? He said, no. So the good news is I saw it online. It was only $5. The bad news is the teacher was okay. He showed us how to create a bunch of programs, but he never explained what the programs were. He just had us type in this and type in this and type in this and never explained what it was all about. All right. So in other words, what happened was the details were encapsulated from him. That's known as data hiding. And again, we live a lot of our lives that way. I got in my car this morning, put it in reverse and backed out of my driveway. I don't know exactly what happens when I put the car in reverse. I don't have to know. I do care if I put it in reverse and I go forward, but that's not supposed to happen. All right. So now they go through this trips application. And what's different in here? Well, where are you going? How many miles did you drive to get there? And how many gallons of gas did you use? All right. So as it says, it's going to now figure out a collective miles per gallon. All right. And what do we have here? We basically do have our MPG program. All right, except now we've got a destination. So if we're driving someplace, we know where we're going and how many miles it's, how many miles long it is. But it basically is our MPG program. All right. So as it says, the app will calculate and store miles per gallon for one to possibly several trips. So if we look at the JavaScript, what have they done in here? Well, notice what they've done. They've got a class in here called trip. That's an individual trip. And they've got another one called trips. And that's all of the trip that you have in here combined. All right. It's a little confusing, but notice this is singular, meaning it's only one trip. And this is plural with an S on the end, meaning it's multiple trips. All right. I'm not going to go over it any more than that. But you'll notice again, they use that same type of library. All right. So they're combining information together from multiple files. All right. All right. I think this is the last thing that's in here, and then we'll take a break. And that is they talk about prototypes. All right. Now, prototypes are the way you used to do object-oriented programming totally in JavaScript. All right. Some people love prototypes because you can take anything that exists and you can add your own stuff to it without any problems. So in other words, if I thought to myself, I'm using these arrays from JavaScript, and these arrays are part of what's called an array class. And I always wished that an array class would allow you to do this, whatever this is. You can add that to the class itself. All right. And that's what prototypes are. You basically make a copy and then you add to it whatever it is you want to add to it. All right. Now, it's recommended that you don't do things that way anymore. All right. But even still, with the newer way of doing it that I've been showing you all class, a lot of the stuff that's explained in here is still the way it's done behind the scenes. Okay. All right. When they talk legacy code, again, that's stuff that's been around for years. All right. And you're going to find if you look at legacy code, people did it using prototypes. All right. It's not impossible that if you were to get a job where you did JavaScript programming and somebody decided to do this, that they could have you replace all that old legacy code that used prototypes with a newer way of doing things. All right. Okay. Couple last things is a little miscellaneous at the end. More skills for working with objects. Number one, how to use a symbol as a computed property or a method name. Believe it or not, symbol is another kind of variable. For lack of better words, you're creating your own variable. All right. And you'll notice in here, that's what they're doing. So it says a symbol is a native data type that represents a unique value. I have never used symbols in all of my JavaScript code over the years. All right, so I'm not the one to teach you more about it, but it's in here if you want to give it a look. All right. Iterators, we looked at a little bit yesterday. When you're going through something, a list or whatever, you're looping through it, you're iterating your way through it. And they talk a little bit in here how you can use iterators with objects. Again, I'm not going to go through that because it's just it's too confusing. All right. Says iterators are useful, but they require a fair amount of work. So JavaScript also provides what are called generator functions. You can kind of look at a generator function as something that runs when the program starts to put things in their proper place or their proper perspective. All right. Cascading methods, you've looked at these already. We did this with jQuery. You do this and you call this, and the output of this becomes the input into this. Very similar to what we've looked at before. All right. Destructuring, we talked about a little bit. Typically, when you destructure something, you're taking, for an example, an array, and maybe in that array, you've got 10 pieces of information, and you want to be able to pull out just selected pieces of that information and use it. That's destructuring. You can destructure an object just like you destructure an array and only pull out the pieces that you need. All right. And that's what they talk about in here. All right. We're not even going to talk about that. Like I said, this is really getting heavily into it. Finally, they do that task list. This is the last thing that's in here. Notice how it's different. Now you can come in, and when you put up a task, you put in a due date. All right. And when you come in here, you've got links that you can delete individual tasks. You can still click here and clear out all of these, but each task itself has a delete in it. All right. And again, with the JavaScript, they're using object orientation in here and library files. All right. And that's it. A little longer than I thought it would be, but we're going to take a break. But before we do, when you come back from the break, we are going to go into the next chapter, chapter 17. As it says, this is taking your JavaScript to a new level or next level. So we'll talk about functions, closures, and I even added something that I think is mentioned in here, but we'll talk about what are known as IIFEs, IIFEs. It is 9:08. Please come back at 9:20 and we'll pick it up right there. And I'll be right back.
think I told you, Charleston.
This morning we will hear from
All right, looks like it's 9:20, so let's get back into it. The next chapter that we'll go over is on functions and closures and modules. All right. Now, you know what a function is. It's a block of code designed to do ideally one thing, and functions are executed or invoked. We've looked at stuff like this. There's really nothing new there, but there are a few things about functions that you may or may not know. Okay. Functions always have to have parentheses. All right. Functions may return something, don't have to necessarily return something. So again, nothing new there. We've looked at this where JavaScript is one of the few languages where, like right here, we're creating a function expression. All right. We're using a variable to hold the value of a function. We've done this before. All right. We've done arrow functions before. None of that stuff is really new per se. When you create a variable inside of a function, it's a local variable, which means that it can't be used outside of the function in another function unless you pass it to that other function. Again, nothing new there. All right. And if you want a little bit more on functions, okay, I guess probably a lot more, this is the developer.mozilla.org. And I think I mentioned this to you before. I mean, if you do have a desire, maybe not today or tomorrow, but sometime to look at this, all right, what I'll try to remember to do, I've done it before and I'll try to remember to do it again, is I literally went out into this Mozilla developer stuff, and I did this 2 or 3 years ago. So it might be a little bit outdated, but I made 200 videos. They range from maybe 10 minutes long to maybe a half an hour long, that I went over everything that was in here. And I'll try to remember to put that URL out there. It's funny, I've gotten to the point where I don't know how many YouTube people I have right now, but I'd say half, if not more, are people from other countries. All right, I've gotten emails from people in other countries even asking me, hey, could you do a series of videos on this? Well, I will do that if they're part of a class, but otherwise, no. You know what I mean? But I have a lot of this information out there already. All right. Next are closures. This is amongst the hardest thing probably to understand in JavaScript. It says JavaScript variables can belong to the local or global scope. We already just looked at this. If you define a variable inside of a function or method, it's local. If you define a variable outside of any function or method, it's global. That's just the way that works. All right. Now it says a function can access all variables declared inside of itself like this. So in other words, and that should make sense, this function has total access to this variable, okay? But it says a function can also access variables defined outside of a function. It can use this and it can use that because in this case, A is global. Here, A is local because it's defined inside of the function. Here, A is global because it's defined outside of the function. All right. Now, as they mention here in a web page, global variables belong to the page itself. They can be used by basically virtually anything, any script that's associated with a page. But a local variable, as it says right there, can only be used inside of the function where it's defined. All right. Now, notice what it says. Global and local variables with the same name are considered two different variables. All right. And when you modify one, you are not modifying the other one. That can be really confusing. All right. Now in here, we've got my function a equal 4. Well, when we look at this, all right, when you look at it, what do we have there? Well, where was a defined? You have to go in there and look. All right. So it says variables created without a declaration word are always global. Well, what doesn't this have? There's no let, there's no const there. All right. So if you declare variables like that, even though they're declared in a function, they're now global everywhere. Well, one of the things I mentioned at the beginning of the semester, I don't want you doing that. And that's why we've been using or trying to use the use strict. Because if you use strict, doing what they're showing right there is not possible. It's not allowed. All right. Variable lifetimes, global variables, they basically, they last as long as whatever you're working on lasts. All right. Global variables. Local begin life inside when they're declared inside of the function they're declared in. And when the function is finished, they die. All right. So this is where we'll start to talk about something kind of new here. So suppose you want to use a variable to count something. So let's say, for example, every time you create a new object, you want to add one to the count of how many objects you have. And you want this counter to be available to all functions. Okay. It says you could use a global variable and add a function to increase the counter. All right, so what do we have here? We've got this global variable called counter. And here, this is, I would have said plus plus counter, but they did it like that. That's fine. It says the counter should now be 3. Okay. And when you look at it, let's just make sure, let's put a couple more in here. All right, now it should be 5. And you can see it is. Well, that's good, right? It says there's a problem though with this. And that is when you make something global, anything on the page can change it. All right. And I mentioned this much earlier in the semester, but when you do that, when you set up something to be global, where anything can change it, you can run into a situation that's known as a side effect, EFFECT. Sometimes a side effect is what you want. Sometimes it's not. All right. And I've mentioned this before as an example. Some of my information, being an employee of Rankin Technical College, is global. Anybody can go out and find out certain bits of information about me, my name, what I teach, probably my degrees that I have, etc. Some of that information is private to me. All right. Like you, I've got a Rankin number. All right. Since I'm employed here, I've got a salary, etc. So that stuff is known to me, and it's known to a few people at Rankin who work in payroll, etc. All right. Some of that stuff is only known to the people in payroll. They're the only ones who can access it. Now, I might know what my salary is, but I can't go in and let's say that, I think I deserve a 10% raise. I can't just go in there and give myself one. All right. So that would result in side effects, and that's what they're talking about here. So notice what they're doing here. Let counter equal 0, that's fine, but then they're resetting it in here to 0, and they're adding 1 to it. So yeah, it's 1, and you come back in here again, but you reset it to 0, and then you add 1 to it. So you can see when you do that, as it says, it doesn't matter. Again, we can come through here and do this 2 more times like we just did. All right, and run it, and it's still 0 because we're resetting it every time in there to 0. As it says, it does not work because we display the global counter instead of a local one. All right, it says we can remove the global one and access the local one. So there's ways around this, but you're still resetting it in here. And since you're resetting it, every time doesn't matter if it was 50, you're resetting it to 0, which means every time when you run through that, it's going to be 1. All right. So it says a JavaScript inner function can solve this. what the heck is an inner function? It's a function within a function. All right. So it says all functions have access to global scope. All functions have access to the scope above them. So when you have a function within a function, the inner function has access to the outer function and everything that was put in there. All right. So it says, okay, that's fine. So let's try this. All right. So again, what are we doing in here? All right. We're calling this function add right there. Okay. And what's happening? Well, we're setting counter equal to 0. Good. Then we're writing another function that says counter equal counter plus 1. Okay. Okay. But we have to call that function. So we come in here and we do this. And then it comes down and it does this, which makes it do this. And then it returns that. So that should be 1. And indeed, as it says there, it is 1. Okay, well, that's a good start. All right. But it says we need to, if we want to call this multiple times, we need to come up with a way that that line that says counter equals 0 only gets done once. And that's when you use a closure. All right. It looks really weird to look at this. All right. But this line that's in here only gets called once. All right. Then we return this. So we add 1 to the counter, which was originally 0. So it was 1. Then we call it again, and we don't do this again, but we add 1 to the 1, which makes it 2. And then we do it again where it's 3. So again, all right, what is happening in here is every time we are calling this, the count is going up. And again, this is only executing once. What you may or may not have noticed is at the end of this, we've got that. You might say, big deal. It is a big deal because that's what's telling it to actually call the function basically at that time. That's what the closure is. All right. Now, if you remember when we did add event listeners, one of the things that we did was we set something equal to, and we had a function name in there. We did not put parentheses after the function name because what we were doing is we were telling JavaScript, when you click this button, call this function. But now we are telling it to invoke it. All right. All right. And they go through that in a little bit of depth and breadth of coverage. All right. So if you want more than I just gave you on closures, again, this is the page that's in here from developer.mozilla.org. There's also something, and it's going to look very similar to what we just did. This is pretty doggone ugly. All right. But it's called an IIFE, I-I-F-E. All right. If you've got a function that you know is only going to be called once, and you want to define it and call it immediately after it's been defined, you create an IIFE. Okay, I'm just going to leave it right there and just say that. All right, then the last thing I want to mention before we go through the chapter are JavaScript modules. All right, this is going to look very similar to what we just looked at when we talked about a library. Notice modules allow you to break up your code into separate files. All right, so you can have one file that's got stuff in it that uses information from another file that's got stuff in it, that uses information from another file that's got stuff in it, etc., etc. All right. Now, when you do this and you write stuff, you both import things and you export things. So if you look at right here, this import example, this is expecting that there is a file that's called message.js, and we're importing that file. That means that whatever was defined in that file is now going to be available to me in whatever I'm working in right now. So that's importing it, but you can also export. Now, again, why are we going through this? Because in the AWD1111 class that some of you will take next semester and others of you will take either in summer or next fall. All right, this is how most things are done. The JavaScript that you work on in there, you break up into multiple files and you export things that must be exported and you import things that must be imported. In addition to your own stuff, you can import things that have already been written by others or by third parties. All right, so that's what they explain in here. So notice in this case, we've got a file that's called person.js, and there could be all sorts of other stuff in here. It doesn't matter. But what we're exporting is name and age. So if that stuff is imported into a file, now they can use the name and they can use the age. And again, when you first look at this, I mean, when I first looked, I said, that's all fine. I don't get what this buys you exactly. But it buys you the ability to go and partition your program off into different segments. If they're going to be complex segments, you could have different people working on each segment and then put them together. But it is a way of taking and kind of segregating your code out into different chunks and then being able to put the chunks together. All right. If you want more on that, there's the one, the JavaScript modules, okay, from developer.mozilla.org. All right. So let's go in and take a look at what's in the chapter here. And again, I don't think this is going to take real long. I don't remember how long the chapter is, but I'm not going to go into much depth or breadth of coverage. Again, the idea is just to introduce you to this stuff. So as it says, chapter 17, skills working with functions, also introduce you to closures and modules. When you come back on Monday, we're going to talk about Ajax, which is asynchronous JavaScript and XML, and then 19. Now, what about the rest of next week? We're going to go in and we're going to write a few applications together. All right. I'm going to give you, when we do something, I'm going to basically do it. If you want to just watch, fine. You're not going to be responsible for turning it in. All right. But I'm still waiting to hear back from my counterparts at the St. Louis campus. We're going to build a couple applications next week in JavaScript, straight JavaScript. Then, all right, not next week, but the week after that. Okay, so next week we'll build some JavaScript applications. The week after that, again, that's Thanksgiving week. I won't be around the whole week. You'll have time to work on homework, the final test, whatever. All right, but when we get back, which is the week of the 27th, we're going to rebuild these apps and we're going to use something that's called React. I'm still not sure if I'm supposed to give you these and assign them so you have to do them or not. I'm waiting to hear back from Mr. Gudmested and Mr. Gegelman. Once I hear that, I'll let you know. All right. So we're going to start here and right now talk about chapter 17. And you'll notice fairly long chapter. It's about 40 pages, but I think we'll be done sometime around 10. All right. And again, last time I'm going to say this, when we start on Monday, all right, when we start on Monday, I am going to go over the second JavaScript test. If you remember it, it was the one that was called, it had the broken website and it had the different types of games, and it didn't work at all. And I'm going to show it to you and show you how to make it work. So if you've done nothing on that and you want to be eligible for some points, please, this weekend, take the time to try it, do something, turn something in so I can give you some points. All right. And I know Mr. Gegelman is going through the same thing as me with some people not having taken tests yet, etc. All right. So we will talk about basic skills for working with functions, then look at this test scores app. Then we'll look at some basic skills for working with closures and the slideshow app. Finally, we'll look at this module pattern and we'll look at some of the ways this is used. This is about as close as we come until the last chapter of the book that we'll cover next week. This is about as close as we come to what will be in the AWD 1111 class. Database-driven website development 1. All right. So I think you all know how to create a function. All right. I don't think there's anything on this page that people, at least my hope is, that you don't understand. We've created simple functions in here. We've created function expressions in here. We've created arrow functions in here. All right. And all they're showing on this particular page is that it is totally possible to write the same thing in a different number of ways. All right. I've always said, which one do you use? The one that you're most comfortable with right now. All right. Now, if you get a job someplace, that may not be the case. And what I mean is, if you get a job someplace, all right, and in that place, whatever you go to work, if you're working on an application that's real-time sensitive. So in other words, you need the information within 2 or 3 seconds or whatever, you might have to write it a certain way, and that being the fastest way possible. All right. So one thing we haven't talked about are default parameters. All right, so let's look at this example that's right here. Okay, what this says right here in that first line, that const line, there are actually 2 different ways that you can call this calculate tax. You can pass it in 2 values, one representing a subtotal and one representing a tax rate. Or you can pass it in only one value representing the subtotal, and the tax rate will default to 7.4. Now, as another example of this, and maybe I've even given this before, imagine that we were writing some kind of an application for Rankin Technical College itself. All right, and we were having the student pass in a whole bunch of information. All right, and we discover that 95% of the people who go to Rankin live in Missouri. We could default the state then to Missouri or MO, so that if the person was coming here from Illinois or another state, they could still put that in, but otherwise they wouldn't have to fill something in. All right. And what you see in here then are examples of this. So we're passing in 100, which becomes the subtotal. Nothing, so we'll use that. Here we're passing in 100, but we're passing in, all right, we're passing in 0.087, so 8.7% becomes the tax rate, and it replaces that one. Here it's null, which means there is no tax rate. All right, here it's undefined, so we use the default value. Null and undefined are typically things you're not going to be passing in anyway. They're just showing you these. So, as mentioned right here, you can assign a default value to any function parameter. All right. Now, when you do this, when you do it like this, okay, it should be the last one. In other words, the one that you are requiring should be shown before the one that is going to default. You can have as many default parameters as you want. We could have put a subtotal in here. We could have said subtotal equal 1000. Then that would have been, or in this case, 100, because it's using that every time. Then that would have been a default value for the subtotal as well. Okay. Now, we talked about this a little bit yesterday, but it's important that we talk about it again. And that is these rest and spread operators. It says in chapter 15, you use the rest operator with arrays. We looked at it, okay? The next figure shows you how to define a rest parameter that collects one or more values into an array. All right, it says it provides a nice syntax for defining a function that accepts a variable number of parameters, known as a variadic function. This is big stuff. All right. So what this is saying is I can pass in as many subtotals here as I want. And you'll notice here, we've got the same tax rate, but here we're passing in only one thing. Here, we're passing in two things. Here, we're passing in four things. That's the ... It means that there is a variable number of things that we can pass in. All right, this is fairly new. Say probably within the last 5 to 10 years. All right, it used to be much more of a pain in the butt to have to go through this, because when you think about it, just as an example, forget this is even here. All right, let's just say that what we had in here, forget about this, but here, let's say we had in here test scores. And let's suppose I've got 3 classes. And in my 3 classes, and let's say I've got one class with 10 people, one with 35, and one with 50. All right. I couldn't write this. I'd have to actually read in here someplace the number of people I had in the class to go through it. But here, this will handle any number of subtotals. If I had 50 subtotals in there, it would handle all of them. All right. Not only that, you can have multiple spread operators. All right. So here, as it says, they've got a rate and an amount, and here they've got more amounts. All right. So there's a lot of different ways that this can be done. So again, as it says, the rest operator, which is signified with ... And as they mentioned, it allows you to accept a variable number of parameters. All right. It says a function can only define one rest parameter, but if you use the spread parameter, which looks the same, unfortunately, to pass in the elements into a variadic array. All right. Then as it says, a function call can use more than one spread operator. And it doesn't have to be the last one. This won't make a lot of sense until you actually start working with arrays. All right, and I mean arrays in detail. Okay. All right. The next thing that's discussed in here is the this keyword, which we've looked at a little bit. All right. Now, what they get into in here is the fact, again, that this has many different meanings depending upon where you're using it. All right. And I don't want to go into it any more than that because, again, you're probably not going to remember it anyway. With what we're working on here, it's not that it really matters, but at least you know this typically refers to whatever you're currently working with, whatever that is. All right. But it's different between an arrow function and a regular function. How? An arrow function doesn't have a this keyword. All right, a regular function does. Now it says in legacy code, this is the way people used to do things in lieu of, so instead of using a keyword, they used call and apply and bind. All right, using this is much easier. That said, there is still a lot of code out there that uses call and apply and bind. All right, so they've got this test scores application. You've seen this one before more than once. All right, so again, every time you enter a score in here, okay, you update the average. If it's a new high, so if it was a 99, it would go in here. If it was 76, it would go in here. All right, then the last three scores are now it's going to take 77 and throw it aside. And if we put in 100 here, then we'd have 100 here. That would be a new average, and it would be 100, 98, 94. Very similar to a program that we looked at yesterday. All right, and they're going through it in here right now. You can see the this in there, etc. All right, closures, again, I don't even know if it pays to go through this. The idea with closures is that you can have a function within a function. They mention, it says, to understand closures, you need to understand two things about scope. Scope is where a variable is known to the program. All right. It says an object has access to its own scope as well as what contains it. That's the scope chain. So before, when we looked at a function defined within another function, the inner function had access to the stuff in the outer function. All right. Second, it says there, if an object in the scope chain has something that refers to it, it always stays in scope, even if the object that contains it is out of scope. All right, so what they're saying is if I've got a function within a function, it can use the stuff from the outer function, even if that outer function has finished. All right, and the example they give isn't that different from the one that we looked at, so I'm not going to go through it any more than that. All right, then they've got this slideshow application, and good, bad, or indifferent. It's going to look very similar to what we ran before. All right, so it's going to go in every 5 seconds. It's going to give you a new slide, but you can pause it at any time as well. Then when you click pause again, it'll start counting down from 5 seconds and change the slide. All right, so as it says, it's just an updated version of what we saw in chapter 7. All right. It's been rewritten to use closures. So if you have the desire, you can go back and take a look at that. Like I said, I'm just don't want to confuse you any more than I probably already have today. All right. So next then are these IFIs that I mentioned before. And again, IFI is an acronym that stands for immediately invoked function expression. All right. Usually it is called an IFI, and the idea is that you want to define a function one time, call it one time, so you both define it and call it at the same time. And the key to that will again be the parens that you see right here. Okay. So why do you do this? Again, as they mentioned here, and IFI helps keep variables, constants, and functions out of global scope. You don't want those global things, as we already mentioned, because you get those side effects. IFIs can help prevent name conflicts. And as it says, they can be used to create private state for an object if there's things that you don't want shared with the outside world. So again, an IFI is a function defined and invoked in the same statement. All right, that's the biggest thing I can tell you about that. All right, now they talk in here about the module pattern and namespaces. Again, this is getting pretty heavy. All right, so I'm not going to hit into it. Let's just finish this up and quickly here talk about these ES modules. All right, as it says, closures and module pattern provide a way to give state. All right, but they're still hard to work with. So in 2015, so 8 years ago, JavaScript introduced its own module system. They're known as ES modules. All right, and it's that whole idea that I mentioned to you before. They allow you to use the import and export keywords to either send something out to a routine or bring something into a routine. All right, as it says, these items include variables, constants, functions, even classes. All right. Pretty much, I think that's it for the rest of the chapter. I don't think there's anything more in here. I guess, okay, they redo the slideshow app again. And that's it. So when you come in here then on Monday of next week, we're going to finish this up. We're going to talk a little bit about Ajax. If you haven't liked what we've done so far, you probably won't be nuts about this either. All right. And then finally, when we get done with Ajax, if I move up here to about, all right, it was one too many. We're going to talk about Node.js. All right. Believe it or not, you may or may not remember this, but we've already talked a little bit about Node.js. All right. So on Monday, we're going to actually do 4 things. First, we're going to go over JavaScript hands-on test 2, chapters 4 and 5. All right. Then we're going to go over chapters 18 and 19. So chapter 18 on Ajax and chapter 19 on Node.js. Then when we get done with that, I'm going to go back and again, and I got to make sure I send this out to you on Monday. If I haven't already, and if I have, I'm going to send it again. Talk to you about the end of the semester electronic portfolio that you have to create. I'll again create a very simple one for me using Mobirise. All right, I'd recommend you don't use Mobirise, but it's there if you do need it. And then we will use Node.js and we'll take that and we will copy that so that it is out on, we will put it out on GitHub pages. All right, so that's what we'll be doing. And then probably on Tuesday, Wednesday, and Thursday of next week, we're going to start just building some applications. They won't be real difficult, but they'll show you how you can go out and grab stuff from the internet and do maybe a little, if we can, a little bit of work with databases, etc. Then we'll go back, not the next week is Thanksgiving, but the week after that, we'll be in React for 2 or 3 weeks. And then that'll be just about the end of the class. All right. Thanks for sticking around. Have a good weekend. Have a good day off tomorrow, and I will talk to you on Monday morning. Thanks. Hello? Yes, it is. Yes.